Here's a typical projectile motion problem. A ball is thrown horizontally with an initial velocity of 20 meters per second from the top of a tower 60 meters high. Neglect air resistance. There are three questions we need to answer. What is the initial vertical velocity of the ball? What is the total time required for the ball to reach the ground? What horizontal distance is traveled by the ball? The ball is thrown horizontally. So, with this in mind, there is no vertical initial velocity. The entire velocity there is in the horizontal component of it. And our initial vertical component of the velocity is 0. And the entire velocity is horizontal. So what about the second question? What is the total time required for the ball to reach the ground? Well, once the ball leaves the hand that throws it, it will be affected by the gravitational pull. Of course, the ball was affected by gravitational pull even before, but the gravitational pull was balanced by the support of the hand. Now, once the ball left the hand, the gravitational pull is the unbalanced force on the ball, and having the unbalanced force immediately gives our ball an acceleration, the constant acceleration due to gravity. So our ball will be falling down. And since the gravitational pull is the only unbalanced force acting on the ball vertically wise, this vertical motion of the ball is obeying the law or all the rules of the regular free falling object. So we will be pretty much solving the problem of any object that is moving with the constant acceleration. We know that this object is traveling 60 meters. We know that its initial vertical velocity is equal to 0. And we know that this acceleration is acceleration due to gravity. From the fact that our initial vertical component of the velocity is 0, we can transform our formula into this. We know the distance traveled, we know the acceleration at which it was traveled, so we can solve it for time. And it took 3.5 seconds for this ball to fall to the ground. While the ball was falling to the ground, it was also continued to travel horizontally, so in terms of trajectory, it would look something like this until eventually the ball would hit the ground. I want you to realize that this time of 3.5 seconds falling of this ball to the ground would not be affected neither by the increase or decrease in mass of the ball, nor by the initial higher or lower initial horizontal velocity. This ball could have been shot away from this tower at a huge speed, for example 100 meters per second or 10,000 meters per second. It still would take it 3.5 seconds to reach the ground. It would reach the ground at a great distance, but the time it would take for this ball to reach the ground would be the same, because that time only affected by the distance traveled vertically. So now it's time to calculate horizontal distance traveled by the ball. And once our ball thrown away horizontally, it's given an initial push, and now it's moving at 20 meters per second. If there is no force that is acting on the ball and we're neglecting air resistance, then this ball will continue to move at a constant velocity. The object in motion will remain in motion unless there is an unbalanced force acting on it, and once the ball released, there is no force that would be slowing it down or speeding it up. So this horizontal component of the velocity will remain the same. It will be 20 meters per second in any point of the trajectory. So to calculate the horizontal travel of the ball, we will use the formula for the motion of any object at a constant velocity. The distance traveled by the object at a constant velocity is the velocity times the time, and we plug in numbers, which means 20 times 3.5 time traveled, and it gives us 70 meters. So horizontally wise, our ball will travel 70 meters before it will hit the ground. A similar problem, the diagram below shows a student throwing a baseball horizontally at 25 meters per second from a cliff 45 meters above the level ground. How far from the base of the cliff does the ball hit the ground? Neglect the air resistance. Once again, we need to calculate how long the ball will travel horizontally. To do that, and knowing that horizontally our ball will be traveling at a constant velocity, we need to know the initial velocity of the velocity of our object, and we know that, and we know how long it was traveling. So to do that, we need to know how long this ball spent in the air before it hit the ground. So we need to solve the free fall problem. We need to know how long did it take for this ball to fall to the ground. The initial velocity when the ball was initially released in a horizontal direction was 0, so we have this problem. We solve for time, and apparently it takes 3 seconds for this ball to reach the ground. 3 seconds it is in the air before it hits the ground. Now, to calculate the distance traveled horizontally, we just apply the same formula and plug in numbers. Distance traveled by the object that is traveling at a constant velocity is the velocity of the object times the time that the object was traveling. So within 3 seconds at this velocity, the object would travel horizontally 75 meters. It would land 75 meters away from the base of the cliff. Similar problem, slightly different question. The boy on the tower of the height 12 meters in the figure below throws a ball at a distance of 50 meters. This distance is 50 meters. At what speed did he throw the ball? So we know that vertically, horizontally, our ball would be moving at a constant velocity. So to calculate the velocity of the object moving constantly, we need to know the distance traveled and divide it by the time it took to travel. We know the distance, 50 meters. Now we need to find out the time. We need to know how long did it take for the ball to fall from the 12 meters and reach the ground below. So we solve the same problem. We know the acceleration due to gravity is 9.8, and we find out that it took 2.4 seconds for the ball to reach the ground. Now that we know the distance and time, we can plug in numbers, and we'll discover that the boy threw the ball at this velocity of 20.8 meters per second. So this horizontal velocity vector would be 20.8 meters per second long. And it will be the same length of the horizontal vector over here, or over here. It would be the same horizontal component. And the last problem that I want you to look at right now, please pause the video and read the question yourself. Now that you know the problem and you know the question asked, you probably have realized that once again we are solving the same problem. The crate fell out of the plane that was moving initially at that is probably still moving at the velocity of 54 meters per second, horizontally wise. once the crate fell out of the plane, there is an unbalanced gravitational force acting on it, so it's moving downward as a free-falling object. But it also continues to move horizontally at the constant velocity of 54 meters per second. So at this rate, how far away from that shiny new sport car will land the crate? Will it destroy the car or not? Let's see. Once again, we solve for time. We find out how long does it take for the crate or any other object to travel 130 meters down from the plane to the ground. And once we know the time traveled, once we know how long it took to fall 130 meters, we can solve for the distance traveled horizontally. The horizontal velocity 54 meters per second times the time traveled as it was falling down, and we can see that our crate landed 278 meters away from the shiny new sport car, and this shiny new sport car probably is slightly dusted, but it's definitely not destroyed.